Welcome back, children. Today we are continuing the chapter acids, bases and salts. We have already seen the name and the working of indicators, acid-base indicators. There are two categories of indicators, natural indicators and synthetic indicators or artificial indicators. Can you name a few natural indicators? Yes. A few names of natural indicators. Already we have studied a litmus paper is one such a natural indicator. They are produced from lichen, the natural plant species. Then we have already seen turmeric powder, which is made from turmeric powder by combining with rubbing alcohol. Then the third one we have seen that China rose petals. By mixing China rose petals with water and form China rose indicators. So these are the three: litmus paper, turmeric powder, China rose petal indicators. So all these are natural indicators, but now we are going to study the artificial indicators. So what are artificial indicators? The indicators which are prepared or made from chemicals. We call it artificial indicators. For example, methyl orange, very commonly we use in our laboratories. Methyl orange. And phenolphthalein. Methyl orange and phenolphthalein are artificial or synthetic indicators. How and why we use them? Because they are easy to handle. Okay, they are available in ready-made form from the chemical laboratories. So we purchase from there and use it in our lab. We can also use different types of natural indicators like litmus paper, that is also very common. Methyl orange turns into red. Methyl orange, which is already orange in color, that turns into red in acidic solution. Right? At the same time, they turn into yellow in color in basic solution. So we can understand that the methyl orange turns red in acidic solution and yellow in basic solution. So now you understood what are the color changes shown by methyl orange. Methyl orange turns red in acidic solution and yellow in basic solution. At the same time, phenolphthalein is also very commonly used synthetic indicators. They become colorless. Phenolphthalein is also light pinkish color. They become colorless in acidic solution and dark pink in basic solution. So colorless, the phenolphthalein shows colorless or turns colorless in the acidic solution and become pink in the basic solution. This is all about the artificial indicators, methyl orange and phenolphthalein. Clear everybody? Right. Now we are going to the acids in detail. Okay? Everybody knows acids are sour in taste. They turn blue litmus red. Now some more points. Acids can shows various properties. For example, acids are very good conductors of electricity. Acids are very good conductors of electricity. Acids are corrosive and destructive, and whenever they fall on our body or skin or any material, they corrode the place. Acids react with metals very powerfully. Acids react with metal. Then the metals are destroyed. Acids destroy the metals. So the acids, powerful acids particularly, do not store in metal containers. Acids corrode the metal containers and damage the metal container. So acids are not stored in the metal containers such as aluminum, copper, etc. They are generally stored in glass bottles or plastic bottles. Okay? Acids are stored in glass bottles or plastic bottles. They never store in metal cans, because acids react with metals. Okay? Now, and we are now going to study some other features. There are two types of acids: concentrated acids and dilute acids. Concentrated acids are acids which contain less amount of water or small amount of water, whereas dilute acids contain more amount of water. When acids react with more amount of water, it becomes dilute acids. When acids react with less amount of water, it becomes concentrated. For example, we can see hydrogen gas, hydrogen chloride gas, HCl, hydrogen chloride gas. Hydrogen chloride gas when reacts with water, small amount of water, it becomes concentrated HCl. So how to make concentrated HCl? We can make a concentrated HCl by combining or by mixing the hydrogen chloride gas with small amount of water. You will get a concentrated HCl, hydrochloric acid. To make dilute acid, we can mix hydrogen chloride gas in more amount of water. You know, acids when react with water, they release more heat. It can even explode. When acids react with the water, heat is released. So this can explode and create lot of destruction to the properties. Even the people who work with acids can face this type of heat burns if not taken adequate precautions. So how to dilute the acids? To dilute the acids should be slowly mixed with the water. Take little acid, a small quantity of acid, and take more water. So less amount of acid can dissolve slowly, very slowly, in more amount of water, so that the heat released will be very negligent and small quantity. It will never release a sudden burst of heat and explosion. Never. So small amount of acid react or dissolve in more water. This is very easy technique of diluting the concentrated acids. So how can we dilute the acid? Take small quantity of concentrated acid and dissolve in more water very slowly and rinse the solution, so that the heat generated will be very small and it's not at all dangerous. Today in this part we have studied 4 concepts. What are they? What are artificial indicators? Give example. Okay. Methyl orange and phenolphthalein are the artificial indicators. Methyl orange turns into red in acidic solution. Then basic solution, the methyl orange turns yellow. Phenolphthalein, no color change in the acidic solution, but change into dark pink color in the basic solution. There are 2 forms of acids. Concentrated and dilute acids. Concentrated acid contains less amount of water dissolved in it, whereas dilute acids contain more amount of water dissolved in it. How can we make dilute hydrochloric acid and concentrated hydrochloric acid? Yes. The hydrochloric acid, concentrated hydrochloric acid can be made by passing the hydrogen chloride gas into small amount of water. When hydrogen chloride gas combined with a small amount of water, it becomes concentrated hydrochloric acid. Now to make dilute hydrochloric acid, the hydrogen chloride gas dissolved in large amount of water, then it becomes dilute. Then I told you what are the general properties of acids. I told you 4 general properties of acids. First of all, acids are sour in taste. Okay? Acids, turns blue litmus red. Acids turn blue litmus red. Now, third point, acids are the best conductors of electricity. Acids are the best conductors of electricity because it contains free hydrogen ions. In the acid contains more hydroxyl ions, particularly hydroxyl ions. Free hydroxyl ions are more in acids. So acids are the best conductors of electricity. Now, fourth point, acids are corrosive and they cause damage to clothes, wood and metals. So acids are not stored in metal containers like aluminum, copper, because acids react with corrode the metal and damage the metal containers, and acids will be thrown outside. So this is very dangerous situation. To prevent it, we safely store acids in glass containers or plastic containers of adequate thickness. Now, these are the main concepts from this part. Thank you.